Okay, welcome to 8.1. This is going to talk a little bit more about the moon. Some of the stuff we've already talked about. We're going to go over moon phases again. That'll be in the B part. This is going to be 8.0, and it's going to talk about the Earth's lone satellite, the moon. This is a color enhanced picture. I could have put a regular one up there, but I like this one. It's actually showing a blue moon, which is one of the last things we're going to talk about in 8B. But this would be a blue moon. Beautiful reflection in a crystal clear flat lake. But let's go on to 8A. So some facts about the moon. Moon is our only natural satellite. We've got lots of artificial ones, but it's also only visible because it reflects light from the sun, does not produce its own light. It is our closest neighbor in space. It's roughly 240,000 miles away, and again, we do have Perigee, which is the close moon, and this is Perigeo or Apogeo in the Orbita Luna of Luna going around. And remember, it's a counterclockwise rotation. It's also a counterclockwise revolution, and because of that, and because of the sun's position, we actually see the sun lit, or we have to see the moon lit up, either totally lit up for a full moon or not lit up for a new moon, and we have the waxing phases and the waning phases. We also have a bigger moon called a supermoon, or a smaller moon called the mini moon if we get a full moon where it's closest. Call it a supermoon, or farthest away we call it a mini moon. It also has a misaligned nickel core, very much like our core. Probably, and if you take a look at this picture, you can see the crust is a little thinner on this side than this side. It's sort of skewed off on this one. This one shows a little, probably more drastic, but it actually is pulled towards the Earth, which gives us that synchronous orbit or synchronous revolution where we see the same side of the moon all the time. It also shows on this one where the Maria, big impact Maria, were formed when basaltic lavas from this mantleish area seeped into the crust and filled in those big craters. And again, they're more toward the Earth side than there are away from the Earth side. That could actually be because of the thickness of the moon. Facts continued. Earth wobbles, excuse me, the moon wobbles. And this wobble is called libration. And if you take a look at it, you can see as it goes from a new moon to a full moon, we actually see a little bit more of one side versus the other. And because of this, we actually see more than 50% of the moon. Here's another picture where we see normally, and then sometimes we can see a little bit more of this side, and then sometimes we can see a little bit more of this side. And again, that's libration. It's the moon's liberation. Here's a picture of a full Earth and a full moon when the sun is behind us. So we actually, when we see a new moon, the moon sees a full Earth, and when we see a full moon, the moon sees a new Earth. And you can see these beautiful hurricanes off the coast of North America, west coast of North America. You can see clouds all over. The equator is down here. More facts. Moon has different features that they include Maria, which are the seas, these darker areas. And again, those were high impact molten, mafic molten rock coming out and filling up the craters. And they're mostly roundish in shape. And it also has craters caused by asteroids, large craters. Not quite as large as the Maria, but large in terms of what we see on the moon. And they're a lot easier to see when it gets close to the limb. It's tough to see them here, but if we get close to the day-night line, which we'll see when we talk about moon phases, it's real easy to see these craters because they've got these shadows and high lit areas. Examples of features, they've got seas or Maria, like the Maria Tranquillitatis, or the Sea of Tranquility, or Serenitas, which is the Sea of Serenity. We also have mountains like the Alpine, which are in Italy, and the Alps, which are like in Europe. So they're mountain ranges on the moon also. And they take the names of Earth mountains as opposed to Earth, I guess, emotions. And it also has craters. The large ones are actually named after famous dead scientists, scholars, or artists like Archimedes or Copernicus or Tycho. And the smaller ones actually have more common names. Here are some of the ones like Kepler, Copernicus, Eratosthenes, Plato, Archimedes, and what is it called in math? Parabolas. I don't know. I'm going to try that or this one. But these are actually named after dead scientists or dead politicians or dead somebody. Here's a picture again on the limb of the moon where we actually see lots of really beautiful craters, and you can see craters in craters. And the craters that actually are found on remnants of other craters are younger, so you can see lots of different ages. Trying to see, you can see this crater. If we actually could see this crater touching this crater with other craters inside of it. Well, here's a crater. That one came next. This one came next. But anyway, you can say relative age, older and younger based on craters. So we've got a crater with a crater and a crater. So there's the youngest crater. This one is younger than this crater, and this one is younger than this crater. And then you can see some other younger ones there. 4 theories about the moon's origin. Theory 1 is called the nebular contraction, or when we actually get a nebula that contracted, or condensation theory, where it comes together and then pulls more material together, and you start seeing the formation of the planets forming in the solar system, and then eventually you get the solar system once they've cleaned out their orbits. And we talked about this as the nebular hypothesis for the formation of solar systems, but it also is probably a theory for the moon. Theory 2 is the capture theory, where the moon's over here minding its own business, and a celestial body came too close and got pulled into an orbit, and we trapped it. I'd like you to draw this one. Theory 3 is called the fission theory, where the Earth, primordial Earth, as it was spinning, it actually threw some of its material out, sort of like a lava lamp, and then that one coalesced as the moon. And then theory 4, which is the one we pretty much believe, this is, and I'd like you to draw both of these. Not this one yet, I'll show you another one in a second, but this one basically is the theory which an asteroid or something large called Theia, about the size of Mars, came in, sideswiped the Earth, threw material out, and that material coalesces into what are called moonlets. And actually we got to go from here to there to here to here to here. And eventually the moonlets accrete, or they coalesce into what we say is the moon. And this is the diagram I'd like you to draw. So Theia comes in at an angle and then sends out material. This material coalesces or accretes and actually makes what are called moonlets. And then these moonlets actually come together to make the moon. And that's the one I'd like you to draw. Much easier than the one that was behind it, because that one would be kind of difficult. Spring and neap tides. This is an animation which you'll see actually move, and right here would be the first quarter. And then we move over to a full moon, and then we move over to the last quarter, and then we move over to the new moon. And if you take a look, we have a yellow and a light green and a dark green. And then here we have a smaller yellow, and I don't see the dark green, but I see the light green. And what we have is the yellow is actually the sun's addition, and you can see the sun pulling, and on the opposite side you can see the sun's part of the shadow or part of the tide. And then if you take a look at the moon's tide, we get a much larger tide, and those are called spring tides. So spring tides are when we get the highest high and the lowest low tides, and this occurs during the full moon and the new moon. So it occurs when the moon and the sun, yellow and the light green, making this dark green total. And if you take a look at it, we actually have, let me get to the next one. We have the highest high tides and the lowest low tides at this location. And these tides are especially high when the moon is full or new, when it's closest to the Earth at perigee. If you want to see this one, it's located right here. These are the lowest, and then we have the neap tides. These are the lowest high tides and the highest low tides that are found on Earth. And this is when the moon and the sun fight each other in what's called the first quarter or the waxing quarter or the last quarter, the waning quarter phases. And these tides are especially low when the moon is at apogee, when the moon is farthest away. We actually get a much lesser pull by the moon, so these tides tend to be lower. Okay, here's a site that I'm going to show you. This is actually going to show you all these things, and I'd like you to actually draw this picture where we actually have the sun's pull and the moon's pull when we get a new moon or a full moon, and that's the spring tide. And that's when we actually get these highest high tides and these lowest low tides. And then you can see as we move more towards the first quarter, the tides get smaller and smaller and smaller, and I'll show this to you. And then they get to a neap tide when they pull opposite each other, so that's a first quarter or a last quarter. And then as it moves back towards either the full moon or the new moon, we get larger and larger. It's back to a spring. And let's go ahead and go back to this one. Okay, so here we are located right here, and if I move this around, you can see we get one full rotation of the Earth right there, and you can see the moon has moved from point A to point B, so about 1/15 of the way around. And then I'll just go ahead and let this go. And you can see as we rotate, the moon moves around. This does not show a synchronous orbit. This actually shows the same side of the moon facing the sun all the way around. So this time we would actually get, and here's the neap tide for the first quarter. And for this particular one, and they're actually showing you the tide location here, and I probably should have gone back here and show you the tide view. So we actually have the tide sort of in the middle, and then if you watch the tide go up and down and up and down and up and down and up and down as we rotate in and out of the high tides to low tides, and within a week we get there, and then we're going to move, it's at 7.4 days, we get the first quarter, and I'm just going to let this play, and you can see the tides going up and down. And now what I'm going to do is throw the chart on, and you can see the high tides are getting, as we're getting closer to the full moon, high tides are getting higher and the low tides are getting lower. And then when we actually get to 14.8, I think, days, we actually get a full moon, we get the next spring tide, and we push play, and now the tides, the moon and the sun are going to start fighting each other, and the high tide gets lower and the low tide gets higher. And then we're at day 22.3, and we actually get the next neap tide, and then we move all the way over for 29.5 days, and we'll get the next new moon, the end of the cycle. 29.12, 29.5 days, and we've completed the phase. Okay, so let me minimize this. Let's go on to, actually that's where we're going to stop. That was the end of 8.1b. Thanks for stopping by. Adios.